Okay, let's start today's class, which is optics of the contact lens. So basically, I'm going to talk about optics of the contact lens, core concepts. Okay, so this presentation is made by one of my favorite students. Okay, so what is effective back vertex power? So basically, it's very important, isn't it? In effective back vertex power, whenever we uh, talk about contact lens, it's very central, isn't it? Due to the non-zero vertex distance of a spectacle correction, the far point will lies at the slightly different distance from the two type of correction, so that is spectacle and contact lens power requires correction particularly at eye uh, particularly different. So its basic means why it is there. See, this is the concept. If suppose for plus or minus there is different. Yes, I think it's another picture for minus or not. Yes, no. So for plus, let's take an example of plus. The spectacle is here, yes, and the distance between them, spectacle and contact lens is this. So whenever you change distance, so see, what is the principle of subjective refraction is to secondary focal point of a spectacle, this should lies at the far point of an eye, isn't it? And what is the principle of correction of contact lens? Same, the correction of contact lens should have secondary focal point exactly on the far point of an eye. So, basic thing is whenever you try to focus with a spectacle, the distance is this, the large distance, isn't it? From spectacle to the far point of an eye. Yes, in case of hyperopia, far point is behind the eye. And whenever you try to correct with contact lens, distance is actually shorter in case of plus and exactly opposite in case of minus. So that's why whenever you shift spectacle to contact lens, the power of contact lens we have to increase, isn't it? Because of this, because of this shorter distance of focus, because that's the effective back vertex power, isn't it? And whenever you switch from contact lens to spectacle in plus lens, so power of a plus power of that spectacle decreases as compared to contact lens, and that's the game, isn't it? So that's the chart you always see. This simple chart. This is the simple chart, isn't it? Whenever you use 6 diopter as a spectacle, then for contact lens you have to increase the power. Whenever you use minus 6 diopter for spectacle, then contact lens you have to decrease the power, isn't it? For contact lens you always decrease the power. For contact lens of plus power you have to increase the power. Contact lens of minus power you have to decrease the power as compared to spectacle, isn't it? That's the concept, that's the basic concept. Why it happens? Because whenever you switch the distance from spectacle to contact lens, basically it's because of the secondary focal point should match with the far point of an eye. So far point of an eye doesn't going to change. What we are changing is distance from spectacle or contact lens to the far point of an eye. That's the basic concept. So it's very important that whenever in case of plus power we increase power switching from spectacle to contact lens, and actually increase power from switching to contact lens, and decrease power when switching from contact lens to spectacle. In plus power, in hyperopia, in myopia, exactly opposite. We decrease power when we switch from spectacle to contact lens in myopia, and we increase power from contact lens to spectacle in myopia. That's just reverse. Yes, you have to understand why it reverse. What is the basic principle of optics? It's working. So I have already talked about this concept in my effective optics video, especially in back vertex power, front vertex power, and subjective correction. So I have already talked about it, I think, frequently. You can go to in optics playlist and just watch the things. Okay, so basic concept is this, and basic formula is this. It's always the best formula, isn't it? It's always the best formula. Yeah, spectacle divided by 1 minus d distance, which d is basically vertex distance. Yes, this distance, d into again is spectacle power. That's very simple formula, and this formula is actually what do you call downstream Parisians formula, but I'm not going there. Okay, so basic is this: the vertex distance correction will definitely change the power of spectacle to contact lens, and at the same vice versa from contact lens to spectacle. So we have to be cautious whenever power is greater than 4 diopter, no matter what, plus or minus, isn't it? Less than 4, yes, we do not change. Yes, there is definitely, if there is power, there is change, because when you could change the vortex distance, there will be the change. But it's very important we take it clinically considered amount of refraction is approximately 4. From 4 diopter above in spectacle, we are cautious there. We are always cautious. So it's very important to be cautious whenever you are doing subjective refraction in scleral lens or any RGB lens. So it's very, very important. Or definitely whenever customer comes and then he has very simple power, let's say minus 8, so you have to be cautious whenever from shifting minus 8 spectacle to contact lens. So maybe there is power definitely reduced, and we have to calculate. Yes, definitely we have to calculate, or we have to see at least one chart which is there in clinics and from mobile or internet just searching things. But you have to be cautious why it reduce. Many of the students just remember that in minus it reduce, and many of the student thinks that in plus it also reduce. No, in plus it grows, isn't it? From spectacle to contact lens, minus its reverse, basically diminish power, and plus basically increases the power. So just that, okay. I think I've made the point. So let's moving forward. Is this, I have already told you, whenever in minus 9, so spectacle contact lens power decreases, plus 9 contact lens power increases, isn't it? So that's the graph taken from, I think, Efron, which is very beautiful graph. So you can see whenever you increase power or increase spectacle power basically, so then the contact lens power minus spectacle power always increases, the difference between them increases. Yes, it's very important. This graph is very sweet graph, okay. So what is the effective back vertex power? So one thing that's very crucial, so many of the students get wrong, is whenever you do vortex distance correction in case of cylindrical power, basically toric power, you always take one meridian, okay? Don't do this mistake. Like, see this example. If this is the power, don't do that spherical equivalent in 7 diopter, then convert 7 diopter to whatever power of spectacle contact lens, like example minus 6.5. No, this is wrong, okay. Just convert it first into the cross, okay. Then one meridian at a time, means 90 degrees 8 converted back to 2.72, 6 diopter converted back to 5 minus 5.58. It's very important, just remember. Wait, let me clear it up. It's very important. See, I'll tell you why it's very important. 8 converted to 7.75, 6 converted to 5.558. Now remember, 8 decreases more rapidly compared to 6. Now what happens? It's very important. Now what happened? So just remember these things. What happened then? Because of the reduction, it's very important that cylindrical power gets reduced, isn't it? Because 6 decreases to minus a little bit, but 8 decreases higher, in a higher amount. That's why total cylindrical power even diminishes. So that's the trick. You have to understand that cylindrical power even changes. So it's crucial that you do not use spherical equivalent. Just remember, you do not use spherical equivalent. It will be blunder. Do not use spherical equivalent. Just use a meridian at a time. Okay. Then you formulate a new meridian and then resolve it. This is the power of contact lens. So like 5.58 slash 1.69 into 180. Now this, see, cylinder decreases from 2 1.69, isn't it? So that's the concept. So I don't know. It seems 1.69 or not. Maybe I am wrong. I don't know. Maybe I'm wrong. I think here's another thing also considered here. But whatever, you got the concept, aren't you? I think you got the concept. Basically means, and simply doing mathematics here. Simply resolving the cross. Okay. Simply resolve the cross and finish the thing. That's it. Okay. Fine. Okay, let's move forward. Then the amount of accommodation. This is another very important point. Very important point, and a lot of the MCQs are asked, and even clinical setups. It's very important. It's life saving whenever you try to switch a myopic person in early presbyopic age, and you switch spectacle to contact lens. It will be dis- it will be not good. Patient will feel difficulty. So it will save your clinical judgment too. So what is basically about whenever you switch from spectacle to contact lens or contact lens to spectacle, what happens to the amount of accommodation that people exert? That's very important. So amount of accommodation, vertex distance of lens affects the amount of accommodation. That's the first thing, because whenever we switch spectacle to contact lens, many of the things because of the vertex distance, yes, optics. So myopia stimulates the accommodation increase as the lens move towards the eye. Yes, that's very important. So whenever you switch from spectacle to contact lens, myopic patient accommodate more, because myopic patients feel much more comfortable with spectacle. At the same time, whenever you switch spectacle to contact lens in hyperopic patient decreases the accommodation. So in hyperopic patient, you switch from spectacle to contact lens, they feel comfortable. At the same time, in myopic patient, you switch from spectacle to contact lens, they feel discomfortable. If they are with the accommodation problem too, if they are in early presbyopic phase. So it's very important. So at the same vice versa, if contact lens patients switch to spectacle, then they feel comfortable. If contact lens hyperopic switch to spectacle, then they will feel discomfortable, isn't it? They will exert more accommodation. So feeling comfortable and discomfortable, yes, definitely it's depend upon the patient, but at the same time I'm talking about the concept, the increase of accommodation and decrease of accommodation. It's very important. So this effect increases with the increasing lens power. Is very important. Its effect increases with the increasing level. Its effect is very less when patient has -1 diopter of hyperopia or myopia. Its effect is very high when patient have +10 diopter hyperopia. It's very important. Okay. So see, in this case, if contact lens and spectacle same, this is the case. The comparison accommodation is spectacle, ocular accommodation, and the refraction at 0.33 meter and 0.25 meter. See, 0.25 meter, what you feel is zero diopter. This is two distance, one distance whenever in zero diopter 2.99, and whenever zero diopter 3.8. Contact lens, it remains constant, but at the same time myopia and hyperopia, it remains different. See, whenever it's you are this is spectacle, accommodation decrease in myopia. At the same time, accommodation increase in hyperopia as compared to 2.9. At the same time, this is another chart. Okay, so whenever you move to hyperopia, accommodation increases. In contact lens, it remains constant. Whenever you move to myopia, spectacle correction, so accommodation decreases as compared to contact lens. That's what I'm talking about. Okay. So amount of conversions, that's another thing. It's very important. So that it's always there. This question, whenever you shift from suppose one myopic person to contact lens, what happens to conversion system? What happens to accommodation system? Actually, both increases. Basically, in myopic spectacle, basin effect is there. That's why conversion they converge less and they accommodate less. So whenever they switch from spectacle to contact lens, they have to converge more and accommodate more. So what about the convergence? So spectacle is optically centered on the distance vision, but which are usually for all the distance gaze exert prismatic effect during off-axis viewing. What do you mean off-axis viewing? It means whenever you see for the near. So myopia, whenever patients see from the near, myopic glasses create basin effect, which basically what it does, it helps in convergence. It reduces the convergence effect, convergence effort, isn't it? Basin prism, base out prism, increase the convergence effort, isn't it? So it's very important to understand. So contact lens which move with the eye and remains centered at all distance, the position of gaze, no such a prismatic in contact lens moves when eye moves. So there is no prismatic effect in contact lens, yes. But in spectacle, yes, definitely. Myopic spectacle gives basin prismatic effect. Hyperopic spectacle gives base out prismatic effect. These are all things there. So this is the picture taken from Ola Eickel. So this is what I am talking about. Myopic base out effect. In contact lens, there is no basically, what do you call that, base in or base out effect. That's why myopic converges more with the contact lens, and hyperopic converges less with the contact lens as compared to spectacle, because in spectacle hyperopic converges more, isn't it? In myopic converges less with spectacle. It's very important. At the same time, whenever you switch from the spectacle to contact lens, exactly it's reverse. So contact lens where myopia has to exert more convergence than with a spectacle. Hyperopia, exactly same thing. In hyperopia with spectacle, they have to converge more, but when you switch from hyperopic spectacle to contact lens, they have to converge less. That's really easy for them. So, and at the same time, what about accommodation? Hyperopia accommodate less with the contact lens, and that's why they are in the beneficiary side, because they have to converge less and they have to accommodate less, isn't it? So contact lens wearing hyperopia has exert less convergence than the spectacle. So see, this is the basic thing. Basically means contact lens, they exert this kind of uh, convergence. Whenever in spectacle, see, as the minus power increases, convergence decreases. As the plus power increases, convergence increases. So in contact lens, for certain distance, 0.25 meter, this kind of convergence, and as from 0 is above, convergence decreases. As hyperopia, convergence increases. So can you see, can we see this in another point of view? See, I'm just taking example of this graph. Okay, hyperopia, this much amount of convergence to 22.9, and you switch to contact lens, it decreases, isn't it? Yes. And myopia, this is the amount of convergence for 20 diopter spectacle. Whenever you switch to contact lens, you have to echo convergence more, isn't it? Yeah, that's what I'm talking about. Okay, so for this graph, IPD is taken at 66, versus in 22. So distance from spectacle plane to center of rotation is 27 mm roughly. So what about accommodation and convergence? The amount of accommodation slash convergence ratio, SUV ratio, is same with the contact lens as it with a spectacle, given by author. And if contact lens remains centered for all working distance and the comparison is made with the spectacle center for the distance vision, SUV ratio remains approximately same for both forms. It's very important to understand SUV ratio not change that much with contact lens or spectacle. So it's almost remains same. But with high power, yes, there is little bit fluctuation, but it's not like, yes, there is exactly this type of thing happening there. Okay, so let me summarize this convergence and these things. So basically means myopic correction, what it does, minus lens in front of eye reduces the retinal images, we know that, and reduces the accommodation and convergence demand in spectacle, with spectacle. Okay, but with switching that, increase the accommodation and convergence demand. That's important. Okay, so consequences is what? Myopia may feel more near strain with contact lens versus spectacle. That's the crucial point. So that's why if someone is pre-presbyopic age like 38, 39, and female especially, don't switch her -6 spectacle to -5.5 contact lens. Or if at least you have to switch the contact lens, then tell her it will be problematic, or try to do another things that is important. Just I am not going to cover in this particular PPT. Okay, so hyperpic correction, what it does in the spectacle, with the spectacle increase accommodation and the convergence demand, hyperpic patient. But when switched to the contact lens, reduce the accommodation and convergence demand. So what happens? Hyperpic may find near work easier with contact lens. That's another thing. Prismatic effect at near, what happened? So basically with contact lens, no lens move with the eye, and almost no induced of prismatic, so alters how much fusional vergence is need. SUV ratio with contact lens, SUV closer to the true, so that's why SUV ratio I'm not going to discuss about. Image size, yes, that's crucial, isn't it? Minus lens definitely magnifies, plus lens plus spectacle definitely magnifies. The lens with contact lens, less magnification or magnification with than spectacle. It's very important point. With contact lens, magnification or magnification always diminishes. I will definitely talk about this in another slide. So contact lens, what it does, contact lens reduces the anisoconia and can improve the stereo acuity. It's very important. So one of the best solution for anisoconia is contact lens. Yeah, there are some things, but let's take an example. If there is one eye aphakia and there is no one eye aphakia, yes, single eye aphakia, and there is impossible if there is impossible possibility of um, inserting IOL is very less, then what's the option to improve binocularity? What's the option to prevent myopia? There is only one option, isn't it? That's contact lens. Okay, so multifocal contact lens design, yes, I'm not going to talk about it. Okay, let's move. Aberration, it's very simple thing. Contact lens wearer always look through the point, not from the periphery. So prismatic effect, yes, definitely not there. So near the optical center, if someone is looking through the optical center, many of the off-axis aberration goes, isn't it? So the aberration does not present the problem with the contact lens wearer. So it's not like spectacle aberration. They are not present with uh, contact lens, because contact lens, most of the time patients looking through the or nearby optical center. Okay, that's very important concept. Aberration, the monocular aberration is spherical and coma, so do not present the problem moderate contact lens. Okay, and oblique astigmatism curvature images occur when narrow pencil of yes, definitely. So contact lens fit the eye such a way that the foveal rays is slightly always passes through the point of near optical sensor. That's the concept. Basically, foveal line of sight is always passed through the or at near to the optical center. So this problem do not present. So basically, aberration problem is present in yes, not present in spectacle because of this only thing. The summary: neither chromatic aberration or non-any5 of the monochromatic aberration is likely to present a problem in contact lens. Aberration is out of the context. Yes, definitely correction of the aberration is definitely in the context. So field of view is very simple, taken from old article. So macular field of view is limited only by extent to which eye can move, because contact lens moves when eye moves, isn't it? So normally gives the clear field of view about 100 degree. So by comparison, clear field of view to spectacle wearer is limited by the size and vortex distance. Basically, spectacle field of view is limited by size of the spectacle, at least the what do you call that lens itself, and the vortex distance. So and restricted apparently to 80 degrees. It's a comparison. Okay, so there are a lot of things going on between hyperopia and myopia. In myopia is ring diplopia, in hyperopia is ring scotoma. So there are a lot of things going on, but in contact lens moves with the eye. That's why it's not limited field of view. When you move your eye, contact lens moves and field of view is there. Yes. So magnification, that's crucial concept. Okay, I have already talked about it. So any correction, spectacle or the contact lens, can alter the size of the basics of retina. What it actually does, very simple, plain word. In myopic spectacle, they magnifies more, but when it switches to contact lens, magnification gets less. In hyperopia, spectacle magnifies more. When they switch to the contact lens, magnification less. Yes, definitely contact lens will not do zero magnification, but definitely that's the concept. So magnification, spectacle magnification, you know this formula, and where is F, what is this vortex power, and in case of contact lens, vortex distance is 0. A is 3 mm because it's basically from cornea to entrance pupil distance. So if F is 1 diopter, the magnification factor is 0.3% only. Okay. So these are the all formula which is derived, like there are many things here. Okay, so don't panic about it. The magnification of two lenses having the same back vertex powers is affected by their front surface power. We have already talked about in spectacle magnification. Just go back to that video and learned about that what is spectacle magnification. And spectacle magnification, I have already talked about the shape factor. In shape factor, front surface power matters. In shape factor, thickness matters. So so the magnification in shape factor, if the rays tries to entrance people back through the tear lens and the contact lens, the shape factor shown is something like that. Okay, so whatever at the end is the shape factor of the contact lens varies from about 0.3% to about 3%. That's the concept. Okay, so what at the last it does, if typical contact lens, what does is red line, this is the line, and what the thin spectacle lens is this blue line, and what thin contact lens is green line. Let's take example this red line and the green line. Whenever you prescribe spectacle, see this is the fluctuation of magnification which is very rapid from 1. But when you prescribe contact lens, this graph, yes, definitely it goes a little bit higher than this 0 line and little bit lower than that 1 line, but not like spectacle, not like this line. In spectacle, see the magnification difference from 0, magnification difference from 0, it's very high. So that's why magnification produced by imaginary thin spectacle lens and imaginary thin contact lens, rigid corneal, and the total spectacle magnification based on their power and vortex resistance to entrance people. So we have to understand, no matter what, whenever we compare spectacle to contact lens, if it is plus or minus power, I don't care. So plus spectacle will definitely magnifies more, and plus contact lens will magnify but not like spectacle, less magnification towards the 1 means what, no magnification. So minus spectacle definitely magnifies more, but not like contact lens. Contact lens magnifies but very less because it's very close to 1, isn't it? It's very close to 1. So magnification is equal to 1. What do you mean by that? No magnification. Magnification is unity, isn't it? Image size and object size is equal. So in contact lens, it's always nearby 1. See magnification here? But in spectacle, it went higher, it went rapid like this. It's very important to understand this concept. Okay, so magnification in case of anisometropia, refractive anisometropia, so equal unaided retinal image, both are similar length, and thus the spectacle magnification, spectacle and contact lens, has a direct effect on the retinal side. In with spectacle, the difference in magnification between two eyes is large. That's why in anisoconia concept, anisometropic, it's always better to correct with contact lens. Yes, theoretically, refractive anisometropia is better corrected with contact lens. Theoretically, axial anisometropy is better corrected with spectacle, but practically in clinical setup, we always choose contact lens. With contact lens, it's small, providing greater chance of binocularity. Basically, what is small? It's small anisoconia image size. Yes. So axial anisometropia. So what axial anisometropia actually says is unequal unaided retinal image size approximately equal power with a different axial length. Theoretically, spectacle provide better chances binocular vision. Theoretically, just remember that. But it is usually not the case in practice. It's not the case in practice usually. The retinal receptor distribution may be different in two eyes and being more widely spaced in the bigger eyes. So basically, whenever there is bigger eyes, the retinal cells is spread more widely, isn't it? This also reduce the enlargement caused by the longer axial length. So basically, what if the retinal cells is spread in an area? What it does in a brain, minifies it, isn't it? Minification. So basically, visual perception gets minified, and whenever there is a compactness of cells in retina, what happens then? Magnification in the visual cortex. So I think that's the visual perception thing. But yes, there is a thing. So but remember that theoretically, yes, if axial anisometropy is there, you have to correct with spectacle. Yes, yeah, what do you call that? Knapp's law and all these things. But practically, it's always contact lens is preferred in clinical setup. Okay, so let's do few slides and then we finished. So let's summarize it. So vortex distance, the retinal image size in myopia with spectacle definitely magnifies more. With contact lens, definitely magnification is there, but very less. Okay. So myopic switching to contact lens gets slightly larger image compared to spectacle, and it improves the resolution stereo acuity. Retinal image size in hyperopia. Hyperopic plus power magnifies more. Okay, but at the same time, power contact lens magnifies, but it magnifies less in compare with spectacle plus power. Okay, that's good. That's great concept. And then hyperopic switches to contact lens get a smaller image as compared to spectacle hyperopic correction, and but less anisoconia. That's why less anisoconia between the eyes, chances of improvement in stereo acuity is good. So anisoconia, unequal image size between two eyes. Okay, what happened? Can be large anisoconia because of the spectacle. Whenever you switch to contact lens, greatly reduce the anisoconia. Basically means anisoconia means what? Image size in two eyes, difference in image size. So that's why contact lens is always preferred in high anisoconia. I have already talked about you. If there is a monocular aphakia, you don't have anything. You have only one option, that is contact lens. Yes, besides surgery. If pediatric aphakia, yes, that's crucial. So where I'm not going to talk about Philip, yes, it's simple. So that's another slide that I want to show. Relative accommodation demand. See, in minus spectacle, relative less than the theoretical demand. What do you mean by less than the theoretical? Minus spectacle has less than theoretical demand, but minus contact lens is full theoretical demand. What do you mean by that? Full theoretical demand means spectacle is doing less accommodation, isn't it? Yes, at the same time, see, so at the same time, plus spectacle and plus contact lens is another exactly same story. So prismatic, opposite story, then plus. So prismatic effect at 40 centimeter at plus 6 diopter lens. So what it does in minus lens base in effect, so that convergence is less. Contact lens, it doesn't matter, contact lens 0. Plus base out effect, what it does, to force patient to converge more. So retinal image size changes. 6 diopter spectacle, roughly 6% image magnification. 6 diopter hyperopia, roughly 6% image magnification. But what it does, 6 diopter contact lens, roughly 1 diopter 1% magnification. 6 diopter contact lens plus 6 diopter, roughly 1% increase of magnification. Isn't it good? Isn't it that better when we were talking about anisoconia, or when we were thinking about correcting anisometropia? So that's the concept. Okay, that's the concept of optics. So let's come to the tear lens. So tear lens is formed between the posterior surface of the contact lens and the anterior surface of the cornea. So basically posterior surface of contact lens here and anterior surface of the cornea here. So what it does, so anterior surface of the cornea makes the posterior surface of the tear lens, isn't it? This posterior surface. The posterior surface of the tear lens is made by anterior surface of the cornea, and anterior surface of the tear lens made by posterior surface of the cornea. Contact lens, sorry, contact lens, posterior surface of the contact lens. That's very important to understand. Okay, so maybe absent in soft contact lens. Definitely, soft contact lens is just flexure. So there is no tear lens in soft contact lens. If there is, we don't care about it. So basically, this is the concept. See, anterior surface of the eye will create posterior surface of the contact tear lens, and post anterior surface of the tear lens, this is created by posterior surface of the tear lens. That's the concept. Okay, so if it is aligned with the contact, so basically tear lens has power of 0 if it is aligned fit. If we fit flat, the tear lens has power of minus. If we fit steep, tear lens has a power of plus. So that's the concept. Okay, so basically, back vertex power of the contact lens plus back vertex power of the tear lens is ocular refraction. So whenever we are talking about rigid lens, it's very important. It's not just back vertex power of the contact lens. Then we have to add back vertex power of tear lens into the equation. So basically, tear lens and ocular astigmatism is front surface of the corneal astigmatism plus back surface of the corneal astigmatism. At the same time, crystalline lens astigmatism. So basically, tear lens is astigmatism, front surface of the cornea, the effect of liquid lens. So basically what it does, tear lens does, is astigmatism of the front surface of cornea is reduced by tear lens. That's the concept. Okay, so see, power of air on the back surface of the liquid. So we always consider there is a thin air between the front cornea and the tear lens, and the tear lens and the surface of the contact lens. So if that's the case, then this is a very simple formula we can use and find out the power of uh, front surface of the tear lens and back surface of the tear lens, isn't it? So that's what the concept is. So what it does, what tear lens does, is actually vanish the front surface corneal astigmatism by 90%, isn't it? So when that happens, see, if refractive error is spherical, then spherical cornea either soft or the RGP. So astigmatic cornea is you is soft contact lens. Okay, so it doesn't matter if there is low to moderate cylinder power, then toric soft contact lens can be used, or spherical RGB if refractive astigmatism matches the corneal astigmatism. What do you mean by that? If corneal astigmatism and refractive astigmatism is matches, then RGB can be used, because if the two things are not matching, then what do you mean by that? It means there is internal astigmatism, isn't it? And internal astigmatism we cannot correct from spherical RGB. So higher the cylindrical power, greater than 2.5 diopter, yes, toric soft contact lens. Yeah, if spherical cornea, yes, toric soft contact lens we can use. But at the same time, back surface toric or bitoric RGP or toric silicon hydrogel can be used. Okay, these are the if astigmatism is because of cornea. So it's very important if there is astigmatism is because of cornea or not. If astigmatism is not because of cornea, in this case low to moderate, then you cannot use spherical RGB. You have to use toric soft, or you have to use at least front surface toric RGBs. It's very important. Okay, it's very important. So refractive error is spherical, yes, you can use softer RGB, or yes, definitely. If spherical and there is a astigmatism in cornea, don't use RGB, it will be blunder. You have to use soft contact lens. Okay, because whenever you use RGB, in this case spherical case, but cornea is astigmatic, and then you will see that uh, what do you call internal astigmatism manifested. So it's important to understand this concept. It's very important to understand this concept. I'll definitely going to talk about this concept whenever we're going to talk about astigmatism and correction of astigmatism through contact lens. Okay, so I think this is the last slide, so let me discuss uh, again. So parameters, what is it, and effect, optical effect and clinical consideration. So basically, a thin tear is trapped between the back surface of the rigid lens, maybe, and the front surface of the cornea. Yes, its curvature is determined by the difference between the corneal shape and the back optic zone radius, because back optic zone radius will of the contact lens create front surface of the tear lens, and the corneal surface will create back surface of the tear lens. So effect is act like a small extra lens on the eye. Tear lens acts like a small extra lens on the eye. What is the significance? It's understanding its power is essential to select the correct base curve back surface exam. And it also, what it also does nullify the front surface astigmatism. So formation RGPO, when back surface radius of the contact lens is not equals to corneal curvature, tear lens uh, with the opposite curvature is formed. It's always there. The more steeper the lens, plus tear lens will form. Flatter the lens, minus tear lens will form. It's very important. Okay, flat fitting will create minus tear lens. Steep, tight fitting will create plus tear lens. So you used to correct the astigmatism with the spherical RGP or the toric cornea and to fine tune power. So power, I have already talked about this. This is the simple formula is used there. So steeper fitting, what it creates? It creates plus tear lens. Flatter fitting create minus tear lens. Okay, so that's why In steeper fitting, we add minus power to the contact lens to compensate. That's why steep add minus SAM and flat add plus FAP. This rule came, okay, because flat fitting will create minus tear lens. For minus tear lens to modify, we have to add plus power into the contact lens. So that's why flat fitting add plus to the contact lens. That's why FAP rule. Steep fitting add minus to the contact lens. Yes, this is here, must add minus power to the contact lens to compensate um, tear lens, because tear lens is plus actually. That's why SAM and FAP rule came here. Okay, so astigmatism with spherical RGP on toric cornea, tear lens provide most of the cylinder correction. That's very important. Okay, that's very important. Spherical RGP on toric cornea, especially toric by front surface. Just remember this thing. So only residual astigmatism needs to be corrected by the lens, because RGP, when you fit spherical RGP, the tear lens formed on the back side of the RGP lens will automatically correct the 90% of the front surface corneal astigmatism. It's very important. Okay. So last, in square lens fluid resolved between the lens and cornea behaves as uniform refractive medium. Yes, most of the corneal irregularity and power of the tear layer must be measured over the refraction. So it's very important. Square lens we are going to discuss a lot. Okay, so for now let it be. It's too much long video. Yes, these are my favorite book of all time. Nathan Efron, yes, Phillips, and obviously Clinical Optics by Fenin. And definitely I have taken pictures from old IACL too. So it's long video, but it's worthwhile to watch and try to understand concept. Okay, these are my all-time favorite video for favorite books. Just remember this and try to grasp these two books. It's very good books. Okay, I think that's all. Bis dann. Tschüss.